How many years have you been studying Takt and research? The EBFC show exists to serve people in the construction industry.
So I was fortunate again to learn about Takt from a project, the Women's and Children's Hospital in Sacramento, where Bolt was trying to gain time on their schedule in building the exterior works. And so I think, again, necessity is the mother of invention. They thought they really needed to try something different and explore a multitude of different options. And so they ended up using Takt with amazing results. I then had the chance. I went back to Sutter here in the Bay Area, and I asked for some projects that we had liked to study with my students in class and with our research. And James Pease responded with one project, although it was a little bit too far along at the time for us to do any kind of intervention, any kind of experiment. But then another project came along, the Mills Hospital and the Mills Peninsula Hospital, and the project team was just kind of deciding what kind of lean practices they were going to use on their project. And James Pease introduced my students and me to the project team, talked about Takt, what we wanted to try, and the project team bought on. And so we used Takt as a way to structure the phase schedule. And then we used Takt, of course, in execution of the project. I wouldn't call that first experiment truly Takt planning. It was a complex, it was small, but a rather complex gut and remodel project. So in the traditional sense of Takt planning is often used in like hospitals where you have many rooms that are the same, or hotels or ship building where you have many components that are physically the same or very similar. The project that we looked at didn't have that much similarity from an architectural perspective, from a product component perspective. But I realized at the time that product component repetition didn't really matter. Because we have skilled craftspeople and they have a multitude of skills. They can do many different tasks. So I came through that experiment to the realization that we really needed to focus on what I called work density. And work density is, for a given area, a given scope of work, with your crews, means and methods, prefabrication strategy, whatever you have in mind, how much time are you going to spend in that specific area? And if we can capture that for all the different trades, right, we can begin to balance those times, right? I call these times workloads or work densities. We can begin to play with these numbers. We can change the zoning of the site to even out the workloads across the different trades. And we can also begin to think about trade-offs, right? If I invest a little bit more, maybe to prefabricate a component somewhere else, perhaps it costs more, maybe not, but perhaps it costs more to prefabricate. If I can prefabricate, if I make that investment and I can lower the work density on site, I may be able to actually get everybody to work faster in a faster Takt, in a shorter cycle time on the project itself. So through work density, we can have some really useful conversations about system design.
And through that work density, it doesn't mean that the workers have to perform quicker or harder. Mm-hmm. It just, it actually allows them to perform at an even pace. And this is what I got to learn in Germany with the metaphor of the trains and the tack wagons. The same exact thing as you're calling the density. We just set the wagon size to a certain size. Maybe your wagon is this big, maybe it's this big, depending on the crew mix. Maybe one wagon has a single crew, and another wagon of different production values might require 2 or 3 crews to balance in size to the one crew. So you get the uniform wagon size, and then you create this magical throughput that's just incredible to see